Sorry, please, can you guys see my screen?
Yeah, I can see it from my
And they do plus.
Okay.
That plus
So-
na function in the call for the contract.
Okay, so this is my contract. So this is the contract I created on the Remix ID. So though because I'm coming from a JavaScript background, so I don't know if the way I wrote the contract is correct, but but then this is it. So now if you can look up here, you are going to see my let me start with the explanation you made yesterday for us. This MIT, you say is just like a license, and then this pragma is the compiler solidity you want to use. So me, I use 0.17, just like instructed, above any compiler above this place. I don't know if you guys are hearing me, right?
You can hear you.
Okay. So now this is my contract function called counter. So this is the counter function. So I declared my number, which is using the uint 256. So I made it public so that anybody can verify this number. And I have a function for increase here. This function increase is also a public function, which has a counter num plus plus. So what this means, plus plus means increment, because though in JavaScript, I've not really read deep on this Solidity, but for coming from a JavaScript background, I know when you want to increase a number, you use the increment function. This increment, what is it called? This thing plus plus. So then for my decrease function, also I use minus minus, which is reducing this our number here by one or increasing by one. So if I go to my compile, I compile it, you can see there's no error. And let's go to our deploy and run transaction to see those function in action. So if I come here and deploy my contract, is deployed. So I come to this deploy contract that is one, and I opened it. Now you can see that these are the two functions in my contract, which if I click on this decrease, it has increased this number by one. So if I call this counter num, you are going to see it. We have 10, which is our initial value was 11. So we decrease it. So if I increase it, you are going to see this number is going to go back to 11. So if I click on this increase num and I click the call this counter num again, you see it's 11. Let me increase again, call the counter num, you are going to see 12. But now, sir, I don't know, one of my mistake, I don't know if I'm right, but this is the simple way I think is being done. But now I don't know until I call this counter num, that's when my value is going to show. So that's the place I was stuck. So I don't know how to return it. I don't know if it's to return the num in this function. So that's what I did, sir. But everything is working perfectly. But I need to call this counter num always. I don't know if it's because this my counter num here is a public. So I don't know the corrections. Yeah. Thank you.
Yeah, what you did is I like correct, like perfect. The only thing you needed to add was a function to get the counter num after increment or decrement. That's the only thing you did. I'll grade you 10 over 10. This is absolutely for the fact that like we've not even officially written any code yet, and then you did this. This is perfect. It's perfect. I like it. Congratulations. Thank you very much.
Okay, sir. Thank you. Thank you very much.
Yeah, you can start presenting. Okay, I think we have more than 20 people now. We can like officially start the class, and then like towards the end, the other people we like share their screen and show us what they did. The other, okay, only two people did that. I mean, right? Tech Explorer will share his screen later and show us what he did. For now, let's start the class because we are running late. Please, I want to beg you guys, for those that are not here today, my name is Victor Peter. So I want to beg you guys, please, if you don't understand anything, you don't need to leave the class. By leaving the class, you discourage me. You make me feel like I'm not. Nobody's perfect, right? You make me feel like I'm not doing like teaching well or something, or maybe I'm boring. I know I'm boring because I don't like much talk. I don't talk. I don't like talking to people, but I have to do this. You know, So if you don't understand it, please don't leave. Somebody said this day that most of you don't understand, but you don't feel like asking. You just leave the class. Don't leave the class. We started this series with about 30 students, but towards the end of the class, we finished the class with less than 20 students, and I'm not happy. I felt discouraged this day. So please don't leave. If you have any question, ask me. I will explain to you with my best knowledge. So please, and today's class will be very, very interactive. I'm going to be taking you guys. Um, Let me share my screen. So I'm going to be taking you guys on solidity variables, functions, and data types. So if you don't understand anything, please don't feel difficult. Ask me. I'll explain. Even if I cannot explain to your to your understanding, somebody in the call who understands better will explain to you. It happened yesterday. So please, like I said, today's call will be very, very interactive. I'll ask questions and you too ask questions, please. So we will be discussing solidity variables, functions, and data types today. For those that were not here today, we discussed solidity and introduction to solidity and Ethereum virtual machine (EVM). So and we said solidity is a statically typed contract-oriented programming language designed for implementing smart contracts on the Ethereum blockchain. Though other chains are adopting Solidity now these days. So it is not primarily for Ethereum blockchain anymore. It was primarily for Ethereum blockchain, but now other chains are adopting it. So we list a couple of chains that have adopted Solidity yesterday. So I shared the links. You can ask your classmates or classmates to share the link with you if they have it. So this lesson covers the fundamental building blocks of Solidity, variables, data types, and functions. So here we have a contract called data type. This is not contract that executes any transaction or anything. This is just um, to explain the data types, the variables, and other Solidity fundamentals to you guys. So this contract, there's no error, but there's no functions to execute any special transaction or action. So now let's start with variables. And variables in Solidity are containers for data values, just like in every other programming language. Variables are containers for data values. They are like boxes where you put values inside variables to use later. They store important valuables to be used later when they are needed. So that's one of the simplest form of definition of variables, right? So in Solidity, we have two types of variables. We have state variables. I think there are about three. We have state variables, and then we have local variables. So state variables are permanently stored in contract storage on the blockchain. They represent the state of a smart contract. They are like, should I say they are global? Like every function in the smart contract can see and call use these variables. Unlike local variables that in memory, they are just inside functions and they are only limited to that functions. Their scope ends within that function. They cannot be seen outside that function. Other functions cannot call them. Get there. So when we're talking about state variables, for examples of state variables that are defined inside the contract, outside any functions. For example, this is a contract data types, and this here, all these are state variables. because they are defined outside any function inside the contract.
Sorry, Victor. So sorry, sir. Can you hear me clearly?
Yeah, I can hear you.
Please, your audio is not so clear. It's cracking from my end, and I also confirmed from some of the students. So please, I don't know if you're using a headset or so. It's kind of cracking, maybe something, or maybe from your mic. So they are not
Yeah.
getting you really clear.
Okay, sorry about that now. Is it clear?
Okay, it's moderator. Please, if you can hear from your end, can you just drop a reaction if it's clear? All right, all right. I think it's better now.
Like very, very clear.
Yes,
All right.
but it's kind of cracking sometimes. So but it's better now.
If you continue,
Yes.
let me know. I know what to do. All right. Thank you very
I
much.
think this makes sense. All right, thank you.
So like I was saying, these variables are defined outside of any function, so they are called state variables. These variables are permanently stored in contract storage on the blockchain. They represent the state of the smart contract. So here are some examples of state variables. And to declare a state variable or a variable, you need to do three things. First, you need the data type. What data type of variable you want to create to declare? Like we said yesterday, um, solidity is statically typed. You have to declare the data type you want to use in every variable or function data variables you're creating. You cannot just come and say let's um, state variable equals to this or that. What data type do you want to declare? Is it an integer? Is it a unit, an unsigned integer? Is it a boolean or address? You have to declare it. So here, this is the data type for this very variable, and then you have to declare the visibility. How do you public? Okay, Michael, you have a question.
Yes, good morning, sir. Good morning, everyone. So I'm looking at your terminal now. I'm seeing some words that are together, like your state variable now. So I want to know, is it case sensitive where you have your variable, the V as capital letter and every other thing as small letter? So in a situation where we are writing a smart contract, do we have to be case sensitive about it?
First, you have to be case sensitive. Every variable, like we'll get to like naming convention in Solidity. Every variable, if you want to declare a variable, you have to use split case. Like you start with small data. Every word after the first word or the initial word should have the first letter should be capitalized, just like in this state variable. The first word here has small letter, and the second word, the first letter is the capital letter. So if you go somewhere, like for example, you come down here and you try to call this state variable, and then you use a different letter, like let's say we try to call the state variable here, but with a small letter here, it will throw an error. This, you see, we already have an error here. We already have, so this is not the same thing as this one here. So we have to be, it is case sensitive, and this is the convention for writing, declaring a variable in smart, solidity snake case. It is like, I think it's the same thing in JavaScript, right? So it is case sensitive. I don't know if I answered the question correctly.
Yes, you
Michael,
did, but I want to know the reason why it has to be case sensitive.
it's a convention for every programming language. Okay, somebody's even like answering on the in-call chat. That's the convention for every programming language.
Okay,
So
sir.
if when declaring a variable, you need to do three things. Four things to be precise, but the other one is not compulsory. You can do it with the constructor. So yes, you take the data type and then the visibility. You want it to be public, you want it to be private, external. How do you want it? So then you have to state to give it a name. In this case, we have user data type of unsigned integer. Default by default, this is 256. We have visibility of public and we have a name of counter. So that's one way to declare a variable in that's the way to declare a variable in Solidity when writing a Solidity smart contract. The type, the visibility, and the variable name, right? And like I said, these are state variables because they are declared inside the contract but outside any function. So now I don't know if there's any question regarding that. Before we move to local, I think somebody has a question, right? Get through.
Okay, so from from your explanation, so like state variables now are global variables which can be called anywhere within the function of within our contract as state variables, just like global variables that can be called anywhere within the contract. Or what does state variable do? Because I saw state and then local variable. So is it like global and local still in the same case?
So we state variables, yeah, state variables can also act as global variables, right? But they are not global variables actually. They can only be called within this contract or derived contracts, like contracts that are interacting with this very contract, or contracts you're interacting with within the very contract. So global variables are different. Global variables provide information about the blockchain and transaction properties, and they are available in all contracts. So global variables are like say, we'll get there. Like everything is in this course, so we'll get to that bit. But there's state variables and global variables.
All
Like
right,
for
all
example,
right, cool.
this is your sender. We'll get to that part, right? So there's the block timestamp and there's block number. So we'll get there. So for local variables are only available inside a function. You can see an example here of a local of a local variable. Now any function outside, like inside, within this construct, outside they cannot call this, cannot see or call this, use this variable, this local var, because it is defined within a function. If the scope of this very local variable ends within this function, if I try to call this variable inside a different function, it will throw an error because it's that function. It's, yeah, yeah. Um, somebody had a question, right? Yeah, can you still see my screen? I wonder if I don't take like you can't see my screen. Can you see my screen now? Can you see the ID? Can you see the remix, please? Can somebody unmute and talk to me? Let me know if you can see the remix.
The remix is not seen.
All right. How about now?
We are good.
Okay, okay. So somebody wanted to ask a question, right? Yeah, no question. All right, let's continue. So, like I was saying, this is a local variable defined inside a function which cannot be seen or called by any other function in this contract. And you follow the same way to declare both states and local variables. You need the data type, the visibility, and the name. Okay, initially I said you need to do 4 things when declaring a variable. I didn't explain the last one. The last one is to give it a value, but you don't necessarily do that. And when you don't do that, it defaults to for this one for an integer, the default is 0 if you don't assign a value to any variable you declare. So by default, this is 0. Address, this address is hidden, it's private, can only be seen by within this contract. Outside of this contract can see or call this, see this address. Also, this one, this is important. This can only be seen and called by this very contract. So by default, this address is address 0, something like something like this is address 0, and by default, this is 0. So this is a string. By default, since there's no value, this should be an empty string default empty string, just like in JavaScript. So you follow the same convention to declare both states and local variables, data type, their variable name, and then visibility, variable name, and then the value. So I hope you guys understand the difference between state and local variable now. If there's any questions, anybody doesn't understand, please ask. Before we move further. No question, right? All right. So now let's talk about variable visibility. Okay. Is there a question? All right. So there are 4 variable visibilities, right? Let me zoom out so I can see it clearly on the screen. I don't know if you can see. I'm using a small screen now, so I can't see see everything. If I'm zoomed in, I hope they bring the light. So variable visibility, there's public. Public means that variable is accessible from within and outside the contract. You can see there's explanation here. Can you guys see my screen clearly, or am I too zoomed out? Okay, so variable public means that variable is accessible from within and outside the contract, and it creates a getter function automatically. And then we have private. Private means it's only accessible within the contract that defines them, right? For example, this address can only be seen and accessed by this. Sorry, this mic. It can only be seen and accessed by this very contract because it is defined in this contract. So no external contract can see or access this any variable that is private. And then we have internal, accessible within the contract, and derived contracts. If this contract is interacting with another contract, that contract or those contracts can access any variable that is declared internal. And we have external, only accessible from outside the contract. And this is a function only. That's for visibility. So by this, you should know when defining your variables and functions, and based on what you want, you should know how to declare their visibility. If you want them public, if you want them to be accessible within from within and outside the contract, you can make them public. If you want only your contract to access the variables, then you can make them private. If you want internal, like your contract and derived contracts that are interacting with your contract to access those variables, you make them internal. If you want them to be accessible only from outside the contract, and then you can make them external. That's all about variables. Any question, please ask questions.
So I think somebody asked the question in the comment.
Okay. Yeah. Those are data types. We are getting to data types now. So when I get there, I'll explain data type, the difference between integer and unsigned integer. So we are going there now. And Adela, you have a question, right? Please go ahead and
Yes,
answer.
I have a question.
Okay.
When is it suitable to use internal or external variable visibility?
I didn't get the question right. Why is it?
When will it be suitable to use internal or external variable visibility?
Yeah, based on the explanation here, depending on what you want, probably some people, like probably for security reasons, they might want your variables to be accessible only within your contract. They don't want external contracts to access them. And then at that moment, you make all your variables private. That means only the contract that defines them can access them. Every other contract outside cannot see or access those contracts. Sorry, those variables. But if you want them to be public, if you want every other contract outside the contracts, within and outside the contract to accept those variables, you can make them public. Those are dependent. Those your the answer depends on what you want, how you want interactions with your contract.
Okay, do you have any examples of when you've used it, like that external, especially that external?
When I have used it personally,
Yes.
no. Like they say, okay, like we are in classes today. I I don't have any project on Solidity currently, so I like on my own app. No, I think
Okay.
Solidity contract, or I don't have any project here. Well, most of my projects are in Cairo. So all right. So now let's move to any other question. Okay, data type and solidity. There are different types of data types in data. Yeah, data type and solidity. We have the value type, the one that holds value, and we have bool example. Sorry, guys. Sorry. Sorry. Yeah, question. Yeah, I can't even. Johnson.
Okay, so sorry, sir. When you are talking about declaring these variables, either public, external, or this, so what if we do not specify? So what is the default?
There's no default. You need to specify. If you don't specify, it will try an error. If you don't specify when declaring a variable, like a state variable, it will try an error. Okay, for local variables, you might not specify because already the function is already public. You already specify visibility in the function. If you don't specify visibility for a local variable, it can fly. But for state variable, for example, if I remove, I think there's a default, right? Okay, the default is internal. Yeah, sorry. I should have checked before answering that question. The default is internal. So if you don't specify, you can declare a variable without visibility, but it always defaults to internal. And I don't think that because in the case where you want other contracts outside of the contract, outside of your contract to interact or access those variables, it won't be possible. So you should always like state visibility. Sorry for the initial wrong answer. Sorry, please. So I don't know if I answer your question. If a default, the default is internal. So I don't know. Sorry. Who asked the question? Johnson. Did I answer your question? All right. So data type, right? Okay, like I said, we have various types of data type. We have the value type, types that hold um, values. Example of value types are the Boolean, which are either true or false. And if you declare a Boolean data type without any assignment, the default is false. Always, I think it's same thing with in every other smart any other programming language. I don't know. It is like that in JavaScript. I don't know if it's like that in Python and other programming languages. So we have the boolean for data type that hold value, and then we have integers. Somebody asked the question: the difference between uint and int. So integers, the unsigned integers, these are only positive numbers. They range from 0 to, like for example, for unit 8, a small number. It is the smallest number in Solidity. It's equal to 255. This one holds small values. It is 8 bits. It ranges from 0 to 2 raised to the power 1 minus 8. If you do, I think the answer is 256, right? Okay, take a prayer. I have a question.
Sir, please, your voice is cracking. I've not been hearing you clearly since.
All right, let me do this. I believe you can hear me clearly now. All right. All right. Unit 8 is the smallest in Solidity, and it holds small number values. It ranges from 8, it ranges from 0 to 2 raised to the power 8 minus 1. If you do that calculation, I believe this is the answer. Just by digital, yeah, that's the answer. So you can use this one to hold small values. For example, where you want input for age, the small values, you can use unit 8 for that. And then there's unit 16. This one holds fairly large number than the unit 8. So it is 16 bits, range from 0 to 2 raised to the power 16 minus 1. If you do the calculation, this is the answer. You can use it to hold larger numbers than the unit 8. And then there's the unit 256, which is the largest number, holds up to, I think, 100 or 1 million. And you can use this in the place where you want, for example, you want date of death number, you want to store phone numbers, you want to store other large numbers, you can use this one. Use unit 256. And anytime you declare a unit, if you don't specify the size, just you remove the size, the default will be 256. I said this yesterday. So the default when declaring the unit, the default is always 256. So and then the int, the unsigned integers. These ones both positives and negatives. Like you have this is where you see you have minus this. You cannot give this a value of negative for the unsigned integers. You cannot give it any value, any negative value, or you can do that to the signed integer. So the smallest there is the unit 8 is the smallest. I did not answer for the 816. So the smallest here is the unit 8 from minus 1 to 8. And 8 bits also ranges from minus 2 raised to the power 7 to up to 2 raised to the power 7 minus 1. Please do this calculation. Have something like this. And then there's unit 16. I forgot to add it. And then the unit 256, which is the largest from minus 5,000. You can also use this to hold large number and negative numbers also. Just same as int, right? And we have address. We have address. I'm just waiting for Nico to be like, because my battery is weak. I don't think they do this like battery. I'm very happy to see it doing tonight. Okay, so we have address. For example, we have the recipient address and we have the payable address. The recipient address is like for example, when sending an Ethereum, when sending tokens to address, the address you're sending to, that's the recipient address. Then we have the payable address, means that the address can receive and transfer tokens. Like creating a smart contract that sends tokens. So this is how to create an address that can send or receive tokens, right? And then we have arrays. It's an array. My array is not. Sorry guys, I'm trying to understand something. I need something on here. Okay, let's continue. We have 6 size byte arrays. bytes, like bytes 1, we have byte 1 single byte, which is this size here, and we have byte 32. That's like hash. Any transaction you click, you see transaction. Anytime you create any transaction on the blockchain, it's transaction hash. Okay, you see something like this, transaction hash. So there are bytes, byte 32. Then we have the alone, where you can use to declare status. If, for example, you create a smart contract that sends and receives tokens. So when sending, when it is pending, when it's approved, when it's rejected, you create a status for pending, approved, and then rejected. You can use a name to do that. And then we have the arrays. We have fixed size arrays, then we have the dynamic arrays. We have fixed size array. Fixed size arrays, you give it a size from the initial. You want this array to have 5 elements inside them. So you cannot increase this array. If you try to do it, I think it will overflow. It will even throw an error. So this is the highest you can take. But the dynamic array, you declare an empty array and then you later push, you use a method to push elements inside into the array. If I want you to understand the difference between fixed size array and dynamic array. Fixed size array, they are fixed. Any size you give them, that's the amount of data elements of, like, for example, the size of this is 5. It is fixed, it is not flexible. You cannot add anything inside there in the future. If you try, it will throw an error. Your code will not compile. Or dynamic array, you just declare an empty array. If array of integers, and then you push, you can add as much data as you want in this dynamic array, but you cannot do that in the fixed array. This is the highest you can take. I don't know. Is there any question? Sorry. Sorry, that was a mistake. I'm not supposed to share that. Okay, Jethro.
Okay, to get more clarity on dynamic and that other array within your contract I just skipped. Please, you said dynamic array, you can push a certain number to it or something. So for more clarity now, from the function you wrote, unit length equals to dynamic array dot length, and you are pushing 10. Does that mean we'll have a list of 10 maybe values within the dynamic array when we push it? And then when it's fixed already is 5. Now you are pushing 10 to the dynamic array, and then you are returning the length. Does that mean we'll get 10 values when we push 10 in it? Or I just want to know so that we can be clear about the strict difference between the fixed and the dynamic array. If you can do it for us.
This is just a figure. This is just an element you're pushing into the array. This is just a figure, not the length. I'm adding an element. Okay. An element. This is just 10, just like you have 5 here. This is an element. So
okay, so the length now will be 1.
It will be 1, yeah.
Okay.
So I believe we all understand the difference between fixed and dynamic array. Dynamic array is like elastic in nature. It's flexible. You can add more elements. It doesn't have size. You can add more elements. But for fixed array depends on the size you give it from the initial. So you declare fixed array by like this, an empty array of this is a dynamic array of integers. You can easily switch this to the dynamic array by just giving it a size here. And then instead of dynamic array, I'm just showing an example. Then you add the elements. You add the elements here, just like in this case here. But for fixed array, for dynamic array, you declare an empty array and then you use method to push in elements later. you can always get the length because you don't know how many elements are inside, you don't know the size. You can always get the length in the future by doing length dot, call it a array name and check the length dot length. Length equals to dynamic array dot length. You guys understand, right? Then we have mapping. Okay, mappings are like hash tables that store key value pairs. So they have key, they have values, and they are the pair keys and values, you know. So you can map address into things. You can map address. You can also map another mapping inside the map. Like you can nest mapping. So you can, like, I don't know how to explain this. You can map another mapping, yeah. First, here we are mapping an address, right? Mapping from address to units. And then we are mapping from another map to another map, right? So map are like they are tables that hold key value pairs. You see more of this when we start like because we're going to start the project, so I'll explain more. Here we're mapping from an address to another map. And the map is public. You can also, just like in variables, you can also declare data like mapping can be internal, external, or public. In this case, our own is public. So here we are mapping an address to units, and here we are mapping an address to another mapping. Like with this map, you mapping an address to the initial map here, what you're seeing here. Yeah, I also prepared a theoretical part of this because this is the practical part where I'm explaining. But I also prepared, I'll share the link in towards the end of the course so you can like all go through this on your own and understand the explanation. I can't really share that because the other screen is off and there's no light. I don't know, do you need more explanation on this mapping? If you think I'm not using the other screen, you need to always notify me or just turn your mic and speak. So because I can get really help listen.
Okay, so I'm a bit confused, but I know you treat it like that because the whole idea of mapping that I know as a person is mapping from an object or an array, right? But this mapping we are doing in Solidity, I don't know how it will play, and I'm not seeing anything dot map, so I'm a bit confused. But I know maybe you treat it. So
yeah,
with time we'll see we'll see it maybe.
Yeah, mapping in Solidity is different from mapping in JavaScript. When I was learning Solidity, back then I was thinking the same thing. Where they were saying mapping, I was thinking like, okay, mapping is going to look like in Solidity where you see, for example, you say details dot map, and then you either create a URL or a div that contains that's for front end, that's for JavaScript. This mapping here is different from that one. It's not like that. This is how you map in this is how you map in Solidity. It's totally different from sorry, please let me quickly take this. It's very important. Sorry, guys, I wasn't speaking. Sorry. A very important for giving how to take it. Sorry. All right. So where we are, my battery. Okay. Let me explain mapping to you. Mappings are table or a dictionary that stores value pairs, allowing for efficient data retrieval based on the keys. Understand? So mappings in Solidity, they are totally different from JavaScript or Python. I don't know where Jetro, I don't know where I believe you're coming from JavaScript. So it is not the same thing. This is the syntax for mapping. First, you need the mapping keyword, and then you need the key type. This is here we are using address. Address is the key type, and then the value type, which here is int. Understand? And then we need the visibility. The visibility here is public, and then we need the mapping name. This is the mapping name. In our case, the mapping name is balance, right? Balances. So this is how you map in Solidity. And you can nest map, like nested mappings. Here we are mapping a map. We are mapping to another map, right? We have a, like we start with the mapping keyword. Here, this is the key. This is the value. The value here is really happens to be another map. Understand? And inside that value, and the other map you're using, the value, like the value map you're using is a key and it's also a value. And what the name for this map here is approvals. This is how you map in Solidity. I don't know if you understand that.
Yeah, it's clear now. Thank you.
Okay, and then we have struct. Structs can be seen as, let's say, yeah, I think, let's say struct is like in JavaScript object. And you can custom, like define custom data and you can use data, right? Struct, this word struct is simply structure. And this is how you define the structure. Here you don't need to add visibility name, visibility, or anything. You just use the keyword struct, you give it a name. In this case, we have a struct of user, then we have a string of name, we have a unit unsigned integer of age, we have address, it's name of valid address. Do you understand? So sorry, who can tell me these are variables, right? These are variables that are defined inside the struct. Who can tell me what types of variables these are? They are defined inside the struct, but inside the contract. I don't know if these are states or local variables. Can anybody try?
This is a local variable.
Why is it local?
Because it's inside the contract.
Yeah, even other local variables are inside the contract, but they are still local. Okay, because it's inside the contract, that makes it that makes them local variable, right? Variables. Sorry, I really don't know who's speaking. Johnson, I can't hear you.
Okay, sir. There are state variables.
Why are they state variables?
Because this object is still kind of like a data type, or like kind of like a data type.
Okay, yeah, I think you're correct. These are state variables because they are inside the contract, but this struct is a data type, and struct here is defined inside the contract, right? Not inside another function. And every other functions can see and call the element inside the struct. They are state variables. For example, outside of the struct now, we are using like returning the struct, right? We are using the variables inside the struct, outside of the struct. That makes them state variables, right? So they are state variables. The variables inside the struct are state variables. And this is how they use elements inside the struct. Once one is declared, you define the struct, the name, the keyword is a keyword struct. And then the name, it can be anything, it can be person, it can be Victor, it can be anything. So to define the struct, you use Pascal keys. I don't know if you understand. For example, let's say we have two words. This one to give it a two-word thing. We use Pascal keys by doing this. So we need to change it here too. Same thing with here. Here it's gone. So when defining a struct, you use Pascal keys. The first letter of the first word should be capital letter. The first letter of every word should be capital letter. That's Pascal keys. Do you understand? This is different from variables. When defining the variables, you use snake case, where the first letter of the first word starts with small letter, then the first letter of every other word that's included in the name should start with capital letter. You get, and this is how to use the variables inside. Now we are like, should I say we are destructuring the struct here? We're using the data that comes with the struct, making it public. We're creating a new user with the data inside the struct. So if you call new user now, like let's say we have a function get new user, and we click on get new user, these are the values of the data inside the struct, right? I don't know if you guys understand what he's saying. Since I'm not seeing the other screen, right? You can like just turn on your mic and talk to me when I ask the question.
Yeah, cool, sir.
All right. All right. So let's continue. I don't know if I skipped anything. I don't think, because I might just look at this comment and skip it. But now, somebody asked a question about global variables. Initially, he asked if global variables are the same as state variables, and I said they are not the same. State variables are special variables, right? Global variables are special variables. Global variables, they can be accessible they are accessible in every contract, any contract. Yeah, example of global variables are message of sender, the sender of whoever is sending something, or depending on how you declare your constructor. Message of sender is always the owner of the contract, probably if you have a constructor where you set the message of sender as the owner of the contract. So we have the message of sender address that call the function. Then we have the message of value, the amount of it. It's the call. Usually it is in the smallest amount of Ethereum. I told you yesterday that we have 4 values of Ethereum. We have the Ethereum, we have the linear. Is it linear? Linear of linear. And we have way, and then we have we, which is the smallest. Then we have the block dot timestamp, the current block timestamp, the time at which you sent the Ethereum was sent, the transaction took place. Then we have the block number, the current block number for the transaction. So these are global variables. Understand? They are different from state variables. To whoever has that question, that I hope you like can see the difference between state variables and local variables. All right. So now, this is very important. But function declaration. This is a core part of every programming language, right? JavaScript smart contract. Every programming language, the functions are a set of instructions, right? Block of instructions. Once to carry out, you want your program to carry out, right? So to declare a function in Solidity, to me, it's a bit weird too, because you need the name function. You need to use the full word function. I commented this out because it is causing an error. It's making the code shout. Let me comment it so you see how it looks. So I need to zoom out a bit. So to declare a function, if I want to need to declare a function, right? You can see my screen very well. First, to declare a function, you need the keyword. This is a keyword function. You can only use this word function to declare a function. You cannot give it to, cannot give it as a name to any variable or function or any data type. You can only use it to define a function. And function is a data type, right? So to declare a function, you need the keyword function. Then you need the name. Sorry, I say this I want to need to declare a function. No, not this. I believe it's down there. So you need the keyword function, and you need the function name and anything, and it should be in snake case. The first letter of the first word should be small letter, lowercase, and the first letter of the second word should be first letter of every other word that comes after the first word should be uppercase. And then you need the parameter, the call data. First, in the parameter, you need the parameter type. If it's an integer, if it's a unit, is it a bool, is it address or string? You need to define the parameter type and then the parameter name. For example, let's say we have a bool here, and you need to give it a name. If you have a string here, you still need to give it a name. And the name should always start with lowercase to differentiate between state variables. Yeah, to differentiate between state variables and to differentiate them between state variables or from state variables. Yeah. When we get to naming convention, then this has to do with smart contract security and the rest. So, and then we need the visibility, right? Visibility it can be pure, it can be view. View returns no. Yeah, I'll explain this later. Pure, it cannot read nor write. It doesn't change anything. Just there for this purpose. View can only read but cannot write, cannot change the state. And then we have, for example, you want to make it, is it a payable function? Is it you want a function to transfer it? So if you want the function to transfer Ethereum, then you make it payable. You want the function to be just view to like a getter function. If that's what you want, then you need to state it returns. What do you want it to return? The return type. Is it returning string? Is it returning boolean? Is it returning is it returning address or uint? So you have to state it. I'll show you an example of a function with all these attributes. So I need to comment this out because I don't like the error. So for here, yeah, the function visibility. So for function visibility, sorry, who doesn't understand function? Do I have not shown you an example of a real function here? I'll show you. So let's go there first. So function for the visibility, we have public. If you make your function call public, the function is callable from within and outside the contract. It's the same thing as public variables. If your function is public, contracts outside this contract can access the function. And then you have private. That means your function will only be callable from within the current contract. Any contract outside this contract cannot see or call your function. And then we have internal, callable within the contract and derived contracts. That's contracts that your contract is interacting with can call functions if the function is internal. And then have external, that means the function is only callable outside the outside the contract, and if your functions have plenty parameters or larger parameters, it incurs more gas, pay more gas. Like you spend more gas. I don't know if you understand. More gas efficient for large parameters. So then we have function modifiers, which, for example, I told you about view. View doesn't modify state; it only reads the state. For example, if you're creating a getter function to get the value of let's say an input or a previous function, this is how you use view.
And only make this clearance at your own will. When you want to do a make or do
Sorry, if somebody has a question. So, Joel,
I think his mic is mistakenly on. If you can mute him, sir.
Mr. George can mute him. Mr. George can mute him.
okay.
Come off your mic.
Please, is Josh online? Hello, Josh, please, can you mute Joel? I don't think Josh is online. All right. So, as I was saying, view doesn't modify the state. It doesn't change the state. It only reads the content of the function. The function can only read content of the probably the variable or the function you want it to return. Can only return a value. And then we have pure. Pure doesn't modify. It doesn't read. It's just a pure function. Usually, I'll show you the use case later, sure. And then you have payable that can receive ether. If your function is payable, the function can receive Ethereum. Yeah. And here is an example of a function. And I said, when defining the function, you need some elements. You need the function keyword, and you need a name. This is the name of this very function. The name is add. If a function is add a plus b, and then inside the parameter, you need this function is carrying two parameters. So the first parameter is a parameter of constraint integer, and the name is a. The type is a data type is joint constraint integer. The name is a. Okay, just another question. Go ahead, please.
Okay, so this is your contract now. This is your function in this contract now. You just did there because you did public. Now you called pure and return, because I tried using this return in that my function, which should say I can add return, but I think it's because I did not add this pure return. Then this I would like this return parameters, this events. So I don't know if that was the case that my function, when I deploy it and I call that decrease function, it was not returning the number until I called the counter.
So did you try adding the pure?
Yeah, I was adding the return inside the function, but it was throwing me an error. I think it's because maybe you use this return now, this pure returns events, right?
Yeah. The return shouldn't be inside the function. Like are you using the return inside of the parentheses here?
No. The return is inside this curly braces, the function code block. Yeah.
Okay. Maybe you probably returning a different thing from what you have here. Like for example, what I'm doing now. I state, because if you declare a unit without size, the default is 256, and here I'm returning unit with size 8. You see, it to try an error. I don't know. Did you like hover and get what the error is?
They were telling me about is it pass error, be place error, something like that.
Sorry, paste error,
I said they were throwing me, yeah, pass error.
pass error. So we need to like see the error to understand. Okay, like, can you see my screen?
Yes, sir. Yes, sir.
Okay, like the reading from here now, you understand what my error is. Understand? I don't know
Yeah.
if you can read the complete error message for me. Here you're saying return argument type is in 256 is not implicitly converted to expected type. Yeah, because I'm defining a different unsigned integer here. Which is 256, and then I'm returning unsigned integer 8, size 8. It will throw that error. So anytime you have an error, just hover over the squiggly line, the red line, and then you read what the error message is saying, and then you try to debug, and it will tell you where the error message is, like the line of code. We have example folder, and then you have the contract name, data types. We have this like the line of where the error is coming from, which is exactly where we have our squiggly line. So always read the return this thing, and if you want to return, like creating a getter function to return, always uses what returns. Return exactly what you're passing in as a call data, right? And you should always use pure. Like this cannot read or change the state of the function or the contract. So if I remove this now, to throw an error. Yeah, sorry, not an error in 1 minute. It can still work since it's not an error, but you need it there. So try to do it like this and see if it still throws the error, and let me know.
Okay, sir. Okay, sir. Thank you.
Okay. So like I was saying, you have a parameter of you have two parameters. They are both unsigned integers. The first one is A, the second one is B, and then you're making this function public. As creating a function, this is a public function, and this function returns the same data type we have in the parameter. Always return the same data type we have in the parameter. For example, if you can return multiple data types, you can return different data types. You can also return string together with integer. Like you can just string. Sorry. Anytime you're using string, make sure specify you use the keyword memory to store it in the memory. And let's say we okay, yeah, this is the one because I'm not returning it. So you can return the error. Sorry. Sorry, I'm trying to fix this.
Maybe you need a key and a value that will store the name so that it will automatically call it from, yeah.
Sorry?
Like a key and I said like a key and a value, like you write What we okay.
I'll try to like get this right and explain it better. But what I'm trying to let you know, you can return multiple values, different data types in the same function, right? So like that's all you need to define a function. The function keyword, the name, parameters. You can have multiple parameters, different value data type, and then the visibility, and then the modifier. Is it a return? Is it a setter function? This will make this function just return some values. This function cannot change the state. Understand? Okay, sorry. This function returns a unit of A plus B, right? So there's also a view function that reads state. Well, I believe you all know how to write a function now, to declare a function. Okay, we have a few functions that reach state. Function of get, we have function with get balance with no parameter, the public, and use it returns a unit, right? Returns address. This returns address, the address of this contract. For example, if I like created a function like this is a contract that I can compile and like deploy. Let me try and see if this will compile since it's not a compile. So let's deploy and see for me to do. So I can deploy it. If I look for this function, get balance. Yeah, okay, yeah. This is this function here. This is this function, get balance. So I just click on the balance and it return the balance of the address, the address of this contract. As you all know, this contract has no Ethereum in it. It has no tokens inside. So the balance is 0. I don't know if you guys understand. This function now will return, if you return the balance of the address of this very contract, and it has no Ethereum in it, it's empty, right? So here we have, I would say, sorry, I was like hovering over this. I was supposed to be hovering over this one. But this is a function that reads, it only reads the state. It doesn't change the state like a getter function. But say, it's a getter function. And it doesn't like you can see here, you don't spend too much gas to execute this function. Okay. Now here is the function that modifies state. This function changes the state of the contract. The gas cost is very, very high. You can see here, estimated execution cost is about 2,400, like 245, 224,000 plus. So the difference between this function and this function here is one. This one returns a value, right? Just like I saw when I clicked on the function, it returned the value, the balance of this contract, which was 0. This one is different. This one will change the state, right? Let's say we have a variable counter up here, just like somebody that was Johnson, right? That did that assignment. So let's say we have a variable, state variable counter, and then which we set it to 0 or any number, and then this function, when we click on this function, the counter will increase. I think we have this function here. We have the function in the counter, just the function call. So you cannot do anything here. It's 0. So let's say we create a variable, a state variable there. We call it counter, right? Sorry, what have I did? Yeah, let's say it's public. It's public, and then yeah. Okay, we have this somewhere, right? 10. Oh, we already have counter here, and it's public, so sorry, I'm supposed to click again. So we already have counter. Okay, I think this is the counter, and then we have increment. So we already have counter up there. So if we click on this function here, we have counter, which is 0. So let's look for this increment counter and click on it. Should be it's public. Yeah, it's public. So we should get it. Yeah, this is the increment counter. So initially we have counter set to 0. This is a count, like I was saying, this is a function that can change. This is a function that can change the state, right? Function that modifies the state of the contract. So if I click on this now, and then I come back to get to the counter, you see the value have changed. I don't know if you can see this. Sorry, I don't. This is so quiet. Okay, thank you. So you see it has changed. But if you click on this function here, it does not change the state. This is like a getter function. I see this is a getter function. This is a setter function. It sets the state, it changes the state. And the difference between this is this keyword, this view keyword, and then this return statement. This one telling this function to return an unsigned integer 256. And in this view is setting it to just view. It's like telling you to only read the content and not do anything. Just read the content. That's what this function is doing. It's reading the content of the balance of this very address. But this one is changing the state, right? It's changing the state of this state variable counter. This is state variable. If I click on it again,
increase, it will change again. And once I come here and click here, the value have changed to 2. So that's the difference between state changing function and read only function. This is the read only function, this state changing function. Writes, this one writes, this one reads. This is read only, this is write. Okay, yeah, somebody has a question. Yeah, Johnson. Go ahead.
Okay, in this your code now, when you are saying this is a view function and this one is a setup function, right? Now, what if we want our function in the sense that if we click this increment counter, now instead of we going back to check the current state, how can we achieve that, like in this function, so that when we click on this increment function on our button in our deploy, so that we'll just see the current value of the counter number.
If you want it to like change as soon as you click
yeah, the increment counter, so that you just know the current value instead of you going back to counter to check the current state.
Yeah, you cannot do that. You have to get it. You are getting it from the blockchain. This is stored in the blockchain, right? So you have to have a function to fetch it from the blockchain. You cannot just like it doesn't just read automatically. But I think there is in the future when integrating with front end, there's a subgraph. I don't know if it is included in this curriculum. There's a subgraph which can make can help you read that, like achieve that. Guys, my battery is really going down and light has not come. I don't know if you can see this. I just hope this light comes before this battery goes down. Battery is very weak. But
sorry, sir. Okay, when you are talking about that, so it's just like RPC code now. So we just add it in the function, right?
To get that thing now, instead of going back to click on the counter to get, you can just create a function to get it, right? Function get count, right? Sorry. I'm sorry. I'm switching something. So function get counts, you make it public because you want it to be accessible. You want to like click it, and then it is view because you want to read. This returns returns a unit, right? So it will return, yeah, it will return count. So if I delete this, like let me compile. There. If I come back here, so sorry, you were saying something about creating a function to get, right, Johnson, in your assignment. Is this how you created your function?
No, like sir, I don't know if you get my question. Now, when you are running the function, yeah,
you want it to read as soon as you press increment, it should just read, it should just like increase it automatically, right?
Yeah, instead of me coming back to this counter to click to check the current value. So I just want, if I just click on the increment function one time, it should just show me the current value instead of me coming back to check the counter.
This is not like front end. This is blockchain. You cannot achieve that. You have to fetch it from the. You have to have a function to go fetch it from the blockchain. I don't know if somebody else understands better to like explain to you.
No, I get.
Yeah, so you cannot. So in order not to always go back to the counter, you can have a function like I just created a getter function where you can still click. I know you don't want to click, you just want it to reflect immediately. But even with the getter function, you still have to click on the getter function to give you the value, right? So let's delete this and redeploy so that we can see our getter function. Get count. Okay, here the get count. For now, get count is 0, right? Count is 0. So if you click on the increment count is now 1. You still have to come here and click. But I know Johnson wants to perform magic.
Sir, I don't mind Johnson. He wants a smooth user experience. Now front end guy.
Count is now 1. You have to have a button to get counts. So this is what Johnson did not add to his assignments. Johnson.
No, sir, I add this get count.
No, it's not when you were presenting. I didn't see the get count.
No, it's there. It's there. Just that that was what I was explaining you, that was my only issue, that can't we do it in a way, or is there a mistake that I can do it? I don't want to be coming back to get the current state. So since it's blockchain, you cannot do it like that, like front end, that you just get the current state.
There are libraries to do that, but you can't get them in the front end. When you integrate to the front end, you can Lizzie. Is it Lizzie now? Hello, Lizzie. Can you hear me? All right. Where are we? Is Josh online? Hello, Josh. Can you please help me mute Lizzie?
Thank you, person. Again. You carry play before that for you, but I'm not see. I'm going to say
This was help me mute Lizzie. I don't think Josh is online.
Lizzie.
If you guys can hear me, let's just continue, please.
Okay, no problem, Mr. Victor. Let me get across to George.
All right, thank you. So now you know the difference between these two functions. This function and this function, they are the same thing. They are getter functions. They are view-only functions, read-only functions. They don't modify the state, they change the state. But this one is different. This one has more power, it incurs more gas, more. So, I believe you know how to declare a function. You know the difference between a getter function and a setter function in Solidity now, right? Right, guys. Now, payable function. Functions that can send or receive ether, right? This is a payable function. It's just a name of the function. This is the keyword, the function is here, you're making it public, right? And then this is what makes it payable, like to receive or send ether, right? Each function can receive Ethereum. Hope you guys understand. And see, cost lesser gas even than the read only function, right? Or far less than the
Yeah, I was trying to ask the question, sir.
Okay, go ahead.
Yeah, from the code, and you can just go back to your. Yeah, I just noticed that the table function costs less gas. So why is it so than like the other one?
For let's say, for example, state changing functions, they cost more to execute because I think they perform bigger actions. Yeah, you get like when they change the state of the contract, so you need more gas to execute. But this deposit function now, I don't think there's more action here. I don't have any genuine explanation to this, but I believe. Sorry.
Sir, please, can you come again? I didn't hear you the time you explained the first part.
Okay, this is the first reading source I'm hearing that like part of the class.
So I've been talking, just that I wasn't hearing you clearly and I didn't want to contribute. It's now I just started hearing you since we started.
Like seriously, I did not say anything.
Thor, I said, but Thor, I don't want to be complaining, so I just let it be.
It is not complaining. You ask questions. You draw my attention to where you don't understand or explain. That means you did not explain understand anything in the whole thing that everything I've been saying.
Honestly, sir, I'll just go back to the recording. I will drop my confusions in the group. Honestly, I didn't go. I was just in the class, but I was not following because I wasn't
That's
hearing.
what I was trying to address earlier. If you are not hearing or you are not understanding, you ask questions. You don't just keep quiet, not contribute. Understand? So please always follow up.
Okay, sir.
Okay, so like I said, state changing functions, they perform more tasks. Probably that's why they cost more gas. Understand? But read-only functions, they don't do anything much. They don't change the states. They just read the values of a particular variable or functions and give you outputs. Nothing changes. So they cost less gas. But for this table function, I don't have a genuine, maybe somebody in the group might know better than me why this costs way lesser gas. But this is a genuine question. I myself will probably like read about it, and then next tomorrow in class, somebody should like remind me of let me answer the question. I also need to know because this is a function. This is like a very vital function, an important function that receives Ethereum. It should cost more gas, right?
Yes.
Then it costs way lesser gas than every other function. So I need to understand that too.
All right.
So by the way, you can have
All right.
multiple contracts in one file. Like it's on the same idea. Here we have two contracts. All these ones have been explained to you since it's under a different contract. And then below here we have another contract. Sorry, my system might go off anytime soon. Unless miracle happens and later brings lights. So I was rushing to see if I could finish before the system goes down. So here we have another contract. I decided to create another contract because when I placed the constructor inside of the first contract, it was throwing errors. I didn't want to comment this constructor out because it is important. So I decided to create another contract inside the same working space called IDE. Yeah, sorry, called my contract, so I can explain constructor to you. But before I explain constructor, I want somebody to tell me what these are. I want to know if you understand what's like, for example, Christina did not understand. Somebody should explain to Christina this stuff right here. What are they? Can anybody do that, please?
State variables.
Okay, yeah, state variables. Why are they state variables? Thank you.
They are declared in the contract outside of the functions.
Yeah, they are declared inside the contract, outside of any function, so they can be
Function.
accessed. Yeah, outside of any function, so that they can be accessed by every other function inside this contract, and they are public, so that means they can be accessed within this contract and outside this contract, right?
Yes.
Yeah. So, Christina, I hope you know what these are now. These are state variables because they are declared
Yes,
outside
sir.
of functions. So here we have a constructor with a parameter of initial value. So there's the question, right?
Yes, sir.
Yeah.
What I was asking yesterday was what Akanimo did in his code. Like before you declare that constructor, what I was asking yesterday was the way you have this message does sender, like the way we have that owner now, like address public owner. Can we put space equal to then space msg dot sender directly?
No, you cannot do that. We tried it yesterday, didn't we?
Yeah.
Like we come here, right?
then it won't be in the constructor. Like,
Okay.
mm,
Yeah. Okay, what we tried yesterday was a different one. We tried to like this is what yeah.
yes, this was really what I meant yesterday.
Oh, okay, yeah. Yeah, you can do this. Right?
Okay. Okay.
Okay.
Because I noticed Akanimo did it in his code and it worked. So that was
Okay.
okay.
Okay, now the constructor. The constructor is a special function that runs only once. That's when the contract is deployed to the blockchain. That's only when the constructor runs. I think that's the lifespan of the constructor. It ends there, but it is very, very important. It's a special function. So this is how to initialize a constructor. Here we have a constructor that has you can only have one constructor in a contract. That's why I think we don't have names for constructors, just the keyword constructor, the parentheses, and then the body. The body is usually inside any code inside this only brackets. It's the body. So here we have a parameter of the units, which is with the name of initial value. And now we are like assigning values to what we have here to be used in the future. Here we have public address, and then we are assigning the message of sender. So we have address, yeah, public address, which with name of owner. Now we are assigning the message of sender to the address. Then the color of the function, the color of like functions of this project, this contract, right? We are sending it to the owner, this address will be declared up here, and then we are assigning block the time. This is a global variable, right? I see earlier. These are global variables. These two, they are global variables. Assigning them to the state variables we created here. We created the state variables with no values, and we are assigning these global variables as values to the state variables we created. I don't know if that makes sense. So we are assigning block.timestamp in case we want to get the timestamp when a particular transaction took place. This is how like you can declare it inside the constructor and then use it later. Right? And we have counter. This assigning the whatever input you put there to become the value of this counter we declare here.
So when the constructor like runs, are you
runs,
getting me? I said when the constructor.
Yeah.
When the constructor is being run once within the blockchain, now we can only view. We cannot modify or interact with it. We can only view, right? Do you understand?
I really don't understand.
Okay.
If you deploy this, yeah, I understand you. We can actually, guys, my sister will go off soon. God, that really happened. So we can actually modify since there's an input, right? Let me see. Well, you can't actually see the constructor. Right?
Okay, sorry, sir. So if you cannot see, then what's the use of it? Why do we have it there?
Like I said, you can use them to create variables to use it. Like most these variables, just like in the struct, the one we created is struct, and then we use that struct to create other variables, right? The same way the constructor function, like the definition here says, a special function that runs once in the contract. So you can use this. For example, we say we want to get the timestamp. Anytime a transaction is created, we want to get that timestamp, right? So now we can use these functions to modify other. Yeah, Bella. Sorry, please. You can use that the variables inside here to modify other functions, right? For example, yesterday we used the owner here to create a modifier, a function modifier, to make sure that only the owner of a contract can call a particular function, right?
Yes, sir.
So if, for example, I want only the owner of this function, this contract to call this function, I already declared here that I already assigned the message sender to the owner, this address here. I can come out here and create a modifier using for example, yeah, create a modifier, use only owner, and then use the value here, this owner value, to make sure that only the owner of this contract calls this particular functions. So now we are using data from the constructor to create modifiers. So the constructor is very, very important, right?
Okay.
Okay, sir.
I don't know. My system will go off and we've not finished this class. I don't know how. Tomorrow there's no class, right?
Yes, sir. I don't think there's class tomorrow.
I don't know. Could you guys be chance tomorrow morning so I can like finish up? Or just set the time where I can just come online and finish up?
We can do 2 hours on Saturday.
Sorry?
So if we can do 2 hours on
So what
Saturday.
about
Because some of us have class, some other class.
Yeah.
So if we can
So
do
what
2 hours on
about
Saturday, because some of us like our days are a bit engaged.
You're supposed to be class on Saturday.
Dev hour?
There's a dev hours on Saturday. So it's 1 hour, but we can do 2 hours if it's okay. We can even do maybe from 4 to 6.
Okay, cool. I'll end the class now. I don't want to stop as well.
So what about on Thursday? Cannot add like 1 hour.
All right, no problem. Let's continue chat on the group. I'll drop a message on the group. Right?
Okay, sir.
Okay, sir.